Good day, class. I remain Adeyeye Adeolu Peter, your favorite tutor. So today we want to look at the component of a force. Component of a force. Now, when we're talking about component of a force, what does it mean? The component of a force in a particular direction can be defined as the effect of that particular force in that direction, or the effective value. We can say that is the effective value of that force in that direction, such that if you have a force that is inclined at an angle theta to the horizontal, this force F, the force F is acting on a particle here. Now you can see that this force is not directly horizontal and it's not directly what? Vertical. So it is inclined at an angle to the horizontal, although it is inclined at both horizontal and what? And vertical. It's inclined to at an angle to the horizontal and to the vertical, but we are using the angle with which the force is inclined to the what? To the horizontal. This x direction. Then draw your vertical from here also upward. This what? This y direction. Sorry, this force is now in between x and what? And y. Don't forget that x and y are they are what? They are perpendicular to each other. So anytime a force is inclined, is in between the two perpendiculars, that's in between horizontal and vertical, and you are asked to find the component of that force. This is what you are going to do. Okay, so this is the force F, this x, and this y direction. This is the origin. Now, this is the angle of inclination to the horizontal. So if you are asked to find a component of this force can be resolved into horizontal and vertical component because it is passing in between the two directions, the two axes. Now, what is the horizontal component of this force? This is a trick you will use. Just complete this diagram to make it a rectangle, just like what we did in parallelogram of forces. Your force is acting this way, the particle is here. Now, I'm going to draw from here. I will draw a vertical line from the force. I will draw downward to the horizontal. You can see. Then from here again, I will draw a horizontal. I will draw that horizontal to also meet the vertical. Now, please let me clean this. Let me shift my F here. This is my F, okay? Now, look at this. This is looking like a rectangle, right? All right. So that if this y, what is here going to be? It's going to be what? Y, opposite side of a rectangle. If here is A and here is B, here will also be what? A, here will be what? B. So here is Y, here is Y. Please just follow me. Then, if here is X axis, this horizontal from O to this side, to the right-hand side, what will the opposite side be? Here is also going to be what? X. Now, let me pick this triangle, the triangle where I have theta and what? And F. Now, look at this triangle very well. What does this give us? We have a right angle triangle, so that here is what? 9. This 90, this is perpendicular. This vertical and this horizontal. So the angle between them is 90 degree perpendicular. So that we now have a right angle triangle. So if you are asked to find the component of this force in the horizontal and vertical direction. So this line here, we call it what? Fx. Why this one here, that's in this triangle, in this right angle triangle, we call this one what? Fy. So what is Fy? And what is Fx? So Fx is the horizontal component of the force F, meaning Fx is the effective value of force F in the what? In the horizontal direction. Fx is the effect that this force F we have in the horizontal direction. So, which is the horizontal component. So the horizontal component of the force F is the effective value of that force F in the horizontal direction. The effective value of that force F in the horizontal direction. So, and what is that Fx? Now let's use SOHCAHTOA. I believe you are conversant with your SOHCAHTOA, your trig, all those trig ratios. Since this is a right angle triangle, this my Fx is what? I want to express Fx in terms of theta and what? And F. So Fx is it opposite to adjacent or what? This adjacent to theta. Fy is what? Opposite to theta. Fy is the one facing theta, so it's the opposite. While F itself becomes the what? The hypotenuse. The side that is facing the angle 90 degree becomes the hypotenuse. So I'm looking for Fx in terms of theta and in terms of our force F. So this adjacent and this what? Hypotenuse. So what connects adjacent and hypotenuse? From SOHCAHTOA. SOHCAHTOA. Adjacent and hypotenuse. That's what? All right. That's K, which is now cos theta. So we have that cos theta equals to adjacent. That's Fx over what? Hypotenuse, which is what? Which is F. Now make Fx the subject of formula because it is Fx we are looking for. Okay. So Fx will now be equal to what? This times this, isn't it? That's F cos theta, where Fx is the horizontal component. That is the effective value, the effect that this force F is going to have in the horizontal direction. Okay, that's Fx. For a force F that is inclined at an angle theta to what? To the horizontal. Now, what of vertical component? The vertical component that's Fy of force F of a force F is the what? The effective value of that force in the vertical direction. So what is the effect that this force will have in the vertical direction? That's what? Fy. We are using the same triangle. So let's look at the relationship between Fy, theta, and what? And F, so that we can also make Fy the solid formula, just like we did for Fx here. Now, Fy is the what? Opposite, isn't it? Opposite to theta. Then F remains the hypotenuse. So opposite and hypotenuse, that's what? From SOHCAHTOA. That's so. Now we have sine theta equals opposite. That's what? Fy over F. Now let's make Fy the solid formula. Cross multiply, we have Fy equals what? This times this. F sine theta, where Fy is the vertical component. Now, for you to be able to relate with this better, when most of us, when we were small, very young, we play with toys. So if you have a toy car here, this is a toy car, something like this. All right. So that a small boy now ties a rope to the front and drags. So this is the boy. So he drags with this force in this direction. So you can see this is the force with which the boy drags. Now you can see that this is inclined. This force F with which the boy drags it is at an angle theta to the horizontal. So this is my horizontal. I will draw you the horizontal from the point where the rope is tied to. So this angle theta. Now, for your information, I believe you know that this force we have an effect in two different directions. It's going to have effect in two different directions. And what are the directions? Horizontal and what? And vertical. Depending on how this boy pulls, this force has the capability of dragging this toy car. This is a toy. It has the ability of dragging this toy car. Although it's pulling at an angle to the horizontal, but this car can move on the horizontal plane. That's on the floor. So the toy will move from here. It will be dragged along the horizontal. And then the boy may decide that okay, I want to speed up. Then as it's trying to speed up, what happens? The car jacks up vertically. So that the mouth is lifted vertically upward. Now, the force that tends to pull the car along the horizontal on the floor, that is what we call the horizontal component of that force, which is what? Fx, and is equal to what? The force times what? Cos theta, where theta is the angle of inclination to the what? To the horizontal. While the other force that tends to lift the car, to jack it up so that the mouth is a bit lifted up, that is what? That is Fy, and it is the vertical component of this force F. That's the effect that this force will have in the vertical direction, and which is equal to F sine what? Sine theta. So that is what I mean when I say horizontal and vertical component. So I'm going to give a simple example on that. For example, a boy tried to pull out a nail from the wall. With a cord attached to the head of the nail. If the cord is at an angle, let me use angle 60 degree to the horizontal, and the boy drags, with a force of 40 Newton. Find Roman figure 1 the force which tends to remove the nail. The Roman figure 2 the force which tends to bend the nail. Number 3, suggest what should be done to avoid bending the nail. Or let me say, with the nail. Now, this is question A. Let me put question B now. will the nail be removed or bent from the information provided above? Question mark. Then suggest what should be done to ensure the nail is not bent. Okay. So this is a question. Solution. I know some of us have tried this one at home before. And in some cases, we succeeded in removing the nail without it bending. While in some other cases, the nail bent without being removed. And in another case, the nail was removed and at the same time was what? Bent. So I'm going to draw the vertical wall first. If this is a vertical wall, this is a vertical wall. All right. Now this is the nail. This is the nail. And this is the edge of the nail. Wall and nail. Now we assume the boy is down. So if the nail is up here, like this way, this is the nail. So it ties a rope and then drags this way. So this is the cord. This is the boy down here. So stretches his hand and is dragging the cord. And it's dragging with what force? 40 Newton. Then we are told that the cord is inclined at an angle 60 degrees to the what? Horizontal. So go to where the cord is tied to. From there, draw horizontal in the direction of the boy. So this is my horizontal. The broken line I'm drawing now is the horizontal. So that this is the angle of inclination of the cord to the horizontal, 60 degrees. I believe you are following, right? Okay. Now, the next thing you are going to do, you can decide to complete the triangle. Form a complete triangle. Maybe from here, draw a vertical from here. So that we are going to use SOHCAHTOA, or just apply the formula I gave to you directly. So this is the force. F equals what? 40 degrees. 40 degrees, which is inclined at angle theta equals to 60 degrees. Sorry, 40 Newton, inclined at angle 60 degrees to the horizontal. All right? So the question says, find the force which tends to remove the nail. So can you suggest the force that will remove the nail? Which force is that? Is it the horizontal or the vertical? So the one that will tend to remove the nail is what? Horizontal, which is here. F what? Fx. Why the one that will tend to bend the nail? So I have to draw from here, from where the nail is, draw downward. That's what? You have to face it downward. This is F what? Fy. If you like, you can also complete the rectangle again. Can you see? Draw here. So we need this and what? And this. But we can use this triangle now. We can use this one. Face this one down. This F what? Fy. Then this one to the right hand side. Since here is Fx, here is also what? Fx. So now this one is facing down because we are dragging out down. It's facing right because we are dragging to the right hand side. Right? So right down. Isn't it? Right and what? And down. Okay. In fact, if you look at the triangle formed, the force 40 Newton now looks like the resultant of Fx and what? And Fy. It looks like the resultant again, just like what we did in the previous video. So we have something like this. You have something like this. So that the resultant, this one looks like the resultant now. This 40, this origin, this fx, and this what? Fy. Okay. So what is fx? Fx is the force that tends to remove the nail. And what is fx? That's f cos what? Cos theta. That's Roman figure 1 now, which is equal to 40 times cos 60 degree. That's 40 times 0.5, and that's 20 Newton. So 20 Newton is the one that we tend to remove the nail. Now, the second question says, find the force that we tend to bend the nail. For the nail to bend, the force that we tend to bend it must be what? Must be vertical. So the boy will drag in such a way that the force we drag the nail downward. The nail will be dragged downward, and it is when the nail is dragged downward, that's vertically, that is when the nail is going to bend. So the force that we tend to do that is the vertical component of this force, which is F what? Fy, which is equal to F sine what? Sine theta. F is 40, then sine what? 60. That's 40 times 0.860. And that's 34.64 Newton. That's it. Then, will the nail be removed or bent from the information provided above? Now, for you to answer that question, you don't just say yes or no. You have to look at what you have on the board. Between the horizontal and vertical, which one is more? Horizontal component is less than the vertical component. Vertical is more than the horizontal, right? So because of that, since vertical is the one that we bend the nail instead of removing it, and vertical is more than the horizontal, so the boy did not apply sense. So the nail is going to what? It's going to bend. So the nail bends. It bends because the vertical is more than the horizontal. Then suggest what should be done to ensure the nail is not bent. Now, what will be done is to ensure that the horizontal component is more than what? The vertical component. And how will you achieve that? Make sure that the angle of inclination to the horizontal is what? Is smaller. Is smaller. Now this angle is too big, meaning it's drawing far away from the horizontal. So if I shift the angle closer, so if this is the wall, if this and this is the nail, so if I shift it closer, you can see now. So it's shifting is closer now. Maybe this angle is 20 degree. If you use 20 degree here, you will see that horizontal component is going to be more than vertical. Even if you use 30. Or better still, let the boy just drag directly how? Horizontally. Without an angle to the horizontal. That's going to be better. That's going to be the best thing to do. It's either you reduce the angle to the horizontal, let the force be shifted closer to the horizontal, or just drag completely in the horizontal direction. Let all the force you apply be directly what? Horizontal. So you will notice that the more you shift your force towards the horizontal, the easier it is for the nail to be what? To be removed. So this is going to be the end of this video. Like, comment, subscribe, and share. Thank you.